Hey AP Stats, Mr. Ellinger here, and this is a 2023 video that I'm recording. I'm redoing one here, and so that these links are no longer good. I think the link will be correct in the document I send you, so you can ignore that stuff up there. I'm re-recording it, and then I'll make a new link, and then I'll put that one in to the thing I sent you. All right, so here we go. So sometimes you're going to be asked to describe a quantitative distribution, and you're like, well, what am I supposed to say? Like, I could give you this data. I could say, here are our travel times for work for 13 workers in North Carolina that were chosen at random by the Census Bureau. Describe this data. And you're like, I don't know. It's a bunch of data. It's a bunch of dots. I don't know. What am I supposed to say? And so we're going to tell you exactly what things you should talk about, and then we're going to kind of develop how you talk about those things. So what should you talk about? One of the things you should talk about is you should talk about the center of the data. What's like a typical in the middle-ish kind of, what's a normal number for this distribution? That's the center. You should talk about the shape of the distribution. We've already talked about that a little bit. Is it symmetric? Is it skewed? Making sure I'm doing it from the right perspective. From your perspective, that'd be skewed left. Is it skewed right? What's going on with that? Uniform was mentioned just a moment ago. You should talk about whether there are any outliers. Are there any outliers in the data? And finally, shape. And you should talk about the spread of the data. How spread out is the data? These are the four things you talk about. And if you'll notice, it has an acronym, and that acronym is SOX, just to help you remember it. So shape, outlier, center, spread. But I tend to start with the center because that's, it's like, well, here's a typical number. Here's the number around in the middle of this data. And so I don't go in that order, SOCS, but SOCS is a nice way to remember it. So what different things are we going to talk about with these? We've already talked about a few of the shape ideas. For center, you'll talk about either the median or the mode, and we'll talk about which one in just a little bit. So you've got those. Spread, how spread out is the data? We're going to talk about two in these videos. We're going to talk about range, and we're going to talk about IQR, and that's coming in a little bit. There's another one I'm just going to mention right now, but it won't be covered in the videos. We won't cover it until we come back and start school, and that's a thing called the standard deviation. Stay tuned. We'll also talk about outliers. Is something an outlier? Is it not? Like, is this thing an outlier? Is it not an outlier? Is this one an outlier? Is this not an outlier? We're going to have a more definitive idea about that in just a little bit. And then shape. Like this one, you could say, it's kind of skewed right because the tail extends out to the right-hand side here. And so since the tail is out here, we call it skewed right. Even though most of the data is on the left, we call it skewed right. I know that's a little tricky, but that's the way it goes. All right. So now we're going to go into detail about some of these different things to talk about, and we're going to use this data as an example. So it says the mean of the sample is 30.5. I worked it out. Why would it be odd to say that the typical commute in North Carolina is around 30 minutes? So take a look at the data and think about that. Why would it be weird to say, a typical commute is about 30 minutes? And here's what I would say in response to that. It's like, well, okay, 30 minutes is right around here. And so it's like, well, most of the data is below that. In fact, there's only 3 that are higher than 30 minutes. And 1, 2, 3, 4, 5, 6, 7, 8, and 8 that are below 30 minutes. It seems like saying a typical commute is 30 minutes is kind of strange. Remember, I'm not going to write all the answers down here. You should take whatever notes you need and write them down yourself. If it's a quick thing, or it's a vocab word, or it's a formula, I'll write it down. But sometimes I'm just going to talk, and so you can pause the video and write whatever you need to write for your notes. So it's like that's not really very typical. And you might say, well, why is it so far off? Why is the why is the mean such a bad measure here? Well, it's because of this person, right? You know, this person had a 110-minute commute, and that drove the average way up, because when I was adding them all up, I was adding up all of these numbers, and the 110 really jacked up the average of all the times. I mean, just imagine if there was someone who had like a 4-hour commute and they were way the heck out here on the right. Then suddenly you'd be like, oh, an average commute is like 40 minutes or something, and it'd be like, oh, that's silly, you know, that to say that a typical commute or the center of this data is 40 minutes when it's really just one data point that's throwing this off. And so the mean is not a very good representative of the situation. One vocab word that is kind of helpful here is this word resistant. And resistant means that it's not affected much by outliers. So we talk about measures, things you can measure as being resistant or not resistant. And so the ones that are resistant, they're kind of resistant. They're like, outliers, you will not pull me very far in any direction. So resistant means that outliers don't affect me much. Not resistant means that outliers do affect me. And I'm not very resistant. I just go where the outlier is. So here's a question. Is the mean a resistant measure of the center of the data? And the answer on this one is no, because of the example we've got here. It's like, wow, yeah, the mean can be really affected by outliers. If I had someone with a 10-hour commute, I know it's kind of silly, but if I have someone, and actually sometimes you do get long commutes for jobs like firefighters where they might do a 72-hour shift. So they might have like a 6-hour commute. They might live 6 hours away from where they work, but then they go and they work there for several days and then they go back. So, sorry, a little fun fact there. So the mean is not resistant because an outlier can really affect the mean. But now we say, well, okay, how about the median? Let's find the median of the data points. Now, of course, if they give you the data like this and it's all in order, you can go back to middle school and find the median the way you did in middle school. You can go, oh, mark that one off, mark that one off, mark that one off, mark that one off. Two there, one there, one there, one there, and one there, and there's one left over at 20. And so the median here is 20. And you could totally do that as a totally legit way to find the median, but we're going to talk about when that's not helpful in just a moment. So is the median resistant? And the answer on this one is definitely that the median is resistant. Because this 110, the fact that it was 110 and not like 70 or 50 or something like that, the fact that it was way the heck out there didn't affect the median at all. I just crossed it off and balanced it out with the one down at the bottom here. And so, if it was a 6-hour commute, it's like, that's not going to change the median at all. The fact that it's out there. I mean, the fact that the point is added, it kind of, it's like, well, there's an extra point, so the median might go up. But the fact that it's an outlier doesn't do anything dramatic and doesn't change the median at all. And so the median is a resistant measure. And so the median is actually 20 minutes. And that seems like a much better representative of this data set. If I want to talk about the center of this data, I'd say, well, a typical commute is around 20 minutes. That seems completely legit, because you can see that most of the data points are kind of clustered here around 20 minutes, and 30 was not a very good measure of center. If you were asked, describe the center of this distribution, if you chose to use the mean, we'd say, I don't know, there's an outlier out there. This is not a good situation where you should use the mean. You should use the median instead. And so you might get critiqued over or marked down over your choice of what you use to measure the center. If you've got outliers, then you would want to use the median. If you don't have any outliers, and there's no real skew, then the mean is great, because the mean uses all the data points and is the one that we typically use. All right. Quick side note. How do you find the median of 248 items? Now, of course, the cross-off method is not going to be so good there, and 435 would be even worse, right? So the cross-off method is fine for small data sets. If you have a big data set, then that's kind of difficult. So how do you do it? And we're going to assume that in this case, that the the data points are all lined up in numerical order, so from the smallest to the biggest. Here's how to do it. So if you think about the 248, we need the middle number, right, of 248. The median's the one in the middle. And so so what I think of it is I think of, well, I've got 124 here and I've got 124 there, but there's no number in the middle. So there's 124 numbers here and 124 numbers here, and I want the number that's in the middle right here. There is no number in the middle because I've got an even number. So in order to find the median in this situation, then you would average the 124th and 125th. You'd average the highest number of the bottom half and the lowest number of the top half. Okay? What if you had 435? Well, now there's an extra one. There's an odd number of data points. So I've got this huge list and I'm trying to find the median, and I don't want to cross everything off because that'll take forever. And so how do I do it? Well, what I do is I say, okay, 435, there's one extra number in the middle now because it's odd. So let's subtract that one off. And so we've got 434 others on the outside, and then divide it by 2. And so that gives you 217. So what's going on here then is we've got 217 numbers to start off. We've got one magic number in the middle, and then we've got 217 more numbers afterwards. So the median is the 218th number in the list. So you could make a formula for this. You could say if you had n items, what's the median? And the formula would depend on whether it was even or odd. But I don't think it's a good idea to memorize a formula. I think it's just draw a quick picture. Just say, all right, is it even? Okay, then half and half, and I average the middle 2. Is it an odd number? Okay, take out 1, divide everything else in half, and then I can figure out where the odd number is. I think that's better than trying to memorize a formula. Okay, that's the discussion for the videos for this intro, this August intro of Center. Now we're going to talk about spread. So, how spread out is this data? What's the spread of these data right here? And it's like, how am I supposed to answer that? We're used to mean and median because we ran into that in middle school, but spread, we don't usually talk about, like, how do you describe the spread of a data set? So, there we go. So I'm going to tell you how to do it. There we go. OneNote problems. I'm out of shape, It's been summer. I haven't worked at all over the summer. So, a couple hours, but not much. So I'm going to have to get back in gear here. So the first measure of spread we're going to have is the range. And the range is just the max minus the min. Woo. What's the biggest number? What's the smallest number? Subtract them. So you're basically finding out how wide the data is. So in our example from earlier, let's see, the biggest number is 110 and the smallest number is 5. And so up above, it would be 105 minus, 105. I was getting ahead of myself. 110, don't know what that was. Minus 5, so it's 105 minutes. That's the range. The range is 105. Notice the range isn't from 5 to 110. The range is 105. Okay. Is that resistant? Is the range, finding the range, is that resistant? So I'll remind you of what that means. The question is that number, when we calculate that number, is that affected much by outliers? And it's like, oh yeah, like that 110 had a direct impact on this 105. And because it was an outlier, it made the range really big. I mean, there isn't a range, like there isn't a huge variability in how long the commutes are. Most of the commutes are all, pretty short, but then there's this one huge one that makes the range look really big. So definitely it's not resistant. And so we want a measure of spread that is resistant. We want, what if we had an outlier and we want to describe spread? How could we do that? We need one that won't be affected much by outliers. And that's what we're going to discuss next. It's called the interquartile range. But I'm running out of time on my, semi-free account. And so I'm going to stop this video here and then I'll pick it up in the next video. So So really quick, we talked about range, we talked about mean, median, and resistance, and we talked about how to deal with large sets. All right, next it'll be interquartile range.